All right, so we're going to tackle the easier of the two measurements that we look at with 3D shapes, and this, of course, is our volume measurement we're going to be talking about. And when we talk about volume, what we're talking about is the space inside the shape from a three-dimensional perspective. Emma, focus. Thank you. Okay, so we're talking about the space inside. So if I were to take this, pretend this was a fish tank, and I were to fill it with water, how much water could I put in that fish tank? And so that's what we're talking about when we're talking about volume, right? This three-dimensional measurement. Now, with rectangular prisms or square prisms and cubes, we're looking at a pretty simple formula here. We're just multiplying length times width or depth and height. It's three measurements, right? So when we're talking about these three measurements over here, let's just make a little note over here on the side of our paper. So when we have a one-dimensional measurement, right, we call that length. That would look something like centimeters. That's one-dimensional, like a segment or a line or a ray. When we have two dimensions, right, and those two dimensions are measured by two measurements that meet at 90 degrees, we call that area, right? And so that would look like something like centimeters squared. And when we have volume, we're talking about a three-dimensional measurement. This is essentially three-dimensional area. And so then this is the one that becomes cubed. And this is a common mistake that I see all the time on the assessment, is keeping track of, is it a to the, what this really is it a to the first power, to the second power, or to the third power on the unit, okay? And so keeping track of that when you're writing your units on the assessment is something that you're gonna wanna pay close attention to. That'd be a great thing to go back and double check before you turn your test in. Did I do my unit measures right? Did I include my units, and am I doing area or volume, or is it a single linear measurement like length, okay? All right, so with this one, really very simple to show your work, right? We're just gonna go volume is equal to, and then we have three measurements that we're gonna multiply. So I'd say fill in the numbers, but I think it's pretty obvious what numbers go in here, right? So we're just going to use the three measurements that we have for this rectangular prism, and then go ahead and multiply those up and write your unit out. All right, you should be done, and you should have come up with 3,672 centimeters cubed, right? Who got that right? Let me see. Everybody got that right? Should have got that right. That's really, really easy. All right, good. All right, fantastic. Are we done here, right? I don't need to do another one of these, do I? This is really easy, right? Okay, three measurements, multiply them together. Volume is your cubed measurement. All right, so then let's talk about all of our other prisms. Okay, so again, very easy to know this one, okay? So the volume of any other base-shaped prism, triangular, pentagonal, trapezoidal, you're going to find the capital B area of the base, and then you're going to multiply it by the H height of the solid. This is the line that keeps the two bases separated from each other, height, okay? Not the height that meets at 90 degrees on the flat two-dimensional surface, right? Again, my kids went outside to what? Play. But I took my wife to see the play. Two different meanings of the same word, right? So the height in this particular formula is the height of the solid, the distance which separates the two bases, okay? Okay, so let's start with number 4. Let's highlight our bases for number 4. Go ahead and highlight your bases for number 4. Your bases, right? Here are your two parallel sides that are the same, right? So then the distance that separates those two bases is what? 5, right? That's the height of the solid. That's the distance that separates the two bases. Okay, so we need the capital B area of one of these bases. So what's the formula for the capital B area? Yeah, now this is 1/2 the other base times height, right? Okay, so why don't you write in the numbers that you think go here and here. Let's make sure you get those in the right place. Okay, you got them? You're looking for the, on the flat two-dimensional triangle, two measurements that meet at 90 degrees. Well, you can find the 90-degree marker, right? The 90-degree marker is right here. So we know that this has got to be one of the measurements, so then that has to be the other measurement. Even though there's not a number out here, we know that if we flattened the top base down onto the bottom, it would be the same. So our two measurements are going to be 12 and 7.3. Good? All right, and when you multiply those across, what do you get? 43.8. Good. Okay. All right. Now we can move into finding the volume, which is just the capital B area of our base times the height of our solid. So then our 43.8 goes here, and our 5 goes here. And you write out your answer. 219 cubic feet. That's how we say that. Cubic feet. Okay? Could be squared feet if it was area, feet if it was a length, or cubic feet if it's volume. How are we doing so far? Everybody okay? All right. So then I'm going to skip number 5 because it's just another triangular prism and just like number 4. So I'm going to skip that one. So let's go to number 6. Let's do some highlighting of our bases on number 6. What kind of shape is number 6? Trapezoidal prism. Good. All right. Good. Highlight your bases. What you should have done for your bases. Okay. Now, what is the height of the solid? Aaliyah's right. Yeah, like, you did not. You questioned her. I heard that. She was right the first time. Hey, but you know what? That was good because you gave a defense of your answer, right? Which is that's what I really want you to be able to do in this class. So that was excellent, right? Like you said, no, it's the distance between them. Exactly. That's what I want you to know. Fantastic. Nice job, Aaliyah. Way to go. All right, yeah. So the height is 25, right? Okay, so now we need the area of a trapezoid. Capital B area of the trapezoid. Why don't you write out the formula? Let's see how well you've got this down now. Go ahead, you write it out. What you should have put down for your area formula for your trapezoid should have looked like that. Right? Base 1 plus base 2 times the height. This is the other height. This is the height on the two-dimensional trapezoid, right? So this is the height that meets the base or one of the bases, actually in this case both of the bases, at 90 degrees on the flat two-dimensional surface. Now once you're able to calculate that volume, then all you have to do is multiply it by the height of the solid, and then you can come up with your answer. I'm going to let you do the rest of the problem. Ready to go. Good. 11,187.5 cubic meters. Yeah? Good? Good. All right. Howdy. Thank you very much. All right. Okay. What kind of a shape do we have in number 7? Triangular prism. All right, let's highlight our bases. Let's highlight our bases for number 7. Go ahead. Should have highlighted those two triangles right there. Yeah? Okay, so we need the capital B base area, right? So we need triangular base area, right? So what do we need? What's the formula for the area of a triangle?
1/2 base times height.
1/2 other base times height. So we need two measurements that meet at 90 degrees. All right, where do we see 90 degrees in here?
At the bottom.
Oh, yeah. Here it is, right here, right? Okay, so then that means we need this measurement and this measurement in order to come up with the area of our triangle. Do we? Well, we don't know. We don't know either of them there because we know this one. We know this one. How are we going to figure out this one? Oh, this is a Pythagorean theorem question, right? Because this is A equals what we don't know, and this is B equals, and then if we wanted to transfer this one over here, we could say C equals 32.5, right? Like that. Okay, so let's do a little Pythagorean theorem. We'll do that work over here. Before you do that work, why don't you give yourself a little divider right here? That way, you know, we can keep our number 7 and our number 8 work separate from each other. All right, you go ahead, do some work, have some fun, do some Pythagorean theorem. You think you could do the whole problem? I think you could do the whole problem. I think you should try to do the whole problem. I think it would be good for you. Let's try it. Well, let's put it this way. Once you get that measurement, it's just as easy as the ones we did on the front side. It's just a triangular prism, right? I mean, it's the same thing. Then you just do that little formula up there and then multiply it by the height of the solid. So go ahead, you do that. We'll see what you come up with. The rest should flow pretty easy. Here's the Pythagorean theorem answer. Take a look. 7,160. Look out, let me see. Yes. Whoop, whoop. Good job. Okay. All right, let's take a look at 8. Let's highlight our bases for 8. Let's highlight our bases for 8. All right, highlighted bases on number 8 should look like that. Yeah? Okay. All right, what kind of a shape do we have? What kind of a shape do we have? Trapezoidal. Thank you. Good. Okay, so then what do we need for this one? Capital B base, right? Capital B area of the trapezoid base. So it's what's the formula?
1/2 height times base 1 plus base.
Okay, so we need a little room in there. Okay. 1/2 height plus base 1 plus base 2. Anybody want to give me some numbers? What numbers do we have? Do we know the base measurements?
What? That's the height? What's the name?
Oh, now that's not this height though. This is not the between the two height.
For the, like the 30.6, that's the height, right?
34.6? No, because if you're talking about the flat two-dimensional surface here, you'd want two measurements that meet at 90 degrees. What's that? This is 39.4 because that's 39.4. So I would say yeah, this is 39.4. Of this thing right here? Well, give me two measurements that meet at 90 degrees. No, 35 is not on the two-dimensional surface. That's the base of the solid. Okay, yeah. But that doesn't figure in until we get down here to the volume part. We're talking about what is the base of the flat two-dimensional surface. That was the conversation that was going on if you weren't following it. Right? Because in order to find the area of the flat two-dimensional trapezoid, we need this and two other measurements that meet at 90 degrees. Okay, all right, hang on. Let's talk a little bit more about that. What is this? That's 90 degrees, right? Okay. So we need this measurement and this measurement, huh? Okay, well, do we know this one? Okay, we know that one. All right. Do we know this one? Hey, you tell me it's what? Well, 30.6 goes like this. Yeah, it's not straight, right? Yeah, that would be right. If I took this and I folded it down, it would come out to about here, huh? Well, actually, you know what though? Girls, we're doing math. That's our focus. Okay? All right. I like what you were saying, Max. You were saying that this wasn't straight, right? If we folded it down, that would come out to about here like that, right? So it's a little bit longer. But we couldn't we do this? Could we do this? Like to make this the same distance as this? That's a great question. 39.4 minus 25?
You know, 30.6,
This 30.6, right? So how do we get this right here? Okay, watch what she's saying. Here, watch up here. Tell me if I'm understanding you correctly. You're saying that this is 39.4 here. So if we took off this part, which is 25, we'd be left with this little piece up here. Did you follow that? What kind of a shape is that? The right triangle, huh? And we know two sides of a right triangle. We have a tool to find the third side of the right triangle. What is that tool? It's everywhere. I'm telling you, it's everywhere all year long. Okay. All right. I'm going to write it out like this. Okay, if you're still struggling with what we did, I'm going to write it out like this for you. Okay, watch this. I'm going to go like this. I'm going to go 39.4 minus 25 a squared plus I don't know squared is equal to 30.6 squared. Pythagorean theorem. Okay, I'm going to highlight it up here for you. This distance right here is 39.4 minus 25. What's 39.4 minus 25? 14.4. Look, if you take this 25 right here and you add another 14.4 onto it, you're going to get to the same height as this corner, which runs down 39.4. We're taking the 39.4 and we're splitting it into two parts. 14.4 goes up here, and then 25 goes down here. So we're making essentially an addition problem out of that, which becomes our small side, our small leg, to find our long leg, and we have our hypotenuse. This is the short distance right here. This we don't know, which is what we're trying to find, which will tell us this, which will allow us to find the base and height of the trapezoid. And then this is our hypotenuse here, which is the 30.6. Okay, go ahead and finish it. Your Pythagorean theorem. Let's see what you can do. All right, here's Pythagorean theorem. Did you get 27?
Yay!
All right, good. Okay. So then let's talk about making sure that we get the right numbers in the right places over here, right? So again, remember with the trapezoid, the two numbers that we're adding together, the two bases, those are always the parallel sides of the trapezoid, right? So the two sides that are parallel on the trapezoid, that's going to be 25 and 39.4, right? So we're going to have our 25 and our 39.4 in there. The number that we found using Pythagorean theorem, this distance, which is the same as this distance, that's the height of the flat two-dimensional surface that meets the two bases at 90 degrees. That's what goes in here. That's our 27. Does that make sense? Everybody good with that? Yeah? Okay. All right, and then we just start working up our volume, right? So then this is going to be 231, yeah? And then we've got our, so this is the area of our trapezoid times, what are we multiplying the 231 by? Oh, sorry, it's not 231, my bad, I looked at the wrong problem. How about that? Okay, how about 869.4?
Yeah.
That works better, huh? I was looking at the problem above. 869.4. Okay, so 869.4. What are we multiplying that by? The height of the solid, which is 35, right? Because that's the one we want, which is the distance that separates the two bases, is 35. So then our volume is, I got 30,429 cubic centimeter. How'd we do? Yeah? Good there? Okay. So listen, on the assessment, for questions like these, all of this work is required. Okay? If you don't show me Pythagorean theorem, you can expect a mark down on your work. Okay? If it's a Pythagorean theorem question, you must show your Pythagorean theorem work. Okay? Everybody good? All right, cool. Okay, let's talk about cylinders. Volume of cylinders. Well, that's easy, right? That's like how much coffee should my coffee have? Okay. Yummy. Okay. Again, we have two bases, right, on our cylinders, right, because it's just a circular prism. I'm just going to do this with you. Let's just highlight our bases. You already know what they are. We don't need to stop for that, right? And again, just like with the other prisms, find the area of the base, multiply it by the height h of the solid, right? Well, I mean, then that makes this formula really simple. Pi r squared. What is that? Well, that's the area of a circle, right? And I'm multiplying it by the height of the solid that separates the two bases. Really, really simple. Okay? So it's really just a matter of keeping track of, do I have a radius? Do I have a diameter? You know, and we're going to leave our answers in pi. Okay, so let's do the first one. Okay? Why don't you just do the first one? Go. I think you can do it. I don't do much. Go ahead. All right. 4,860 pi inches cubed, right? Again, so when I ask you for the exact answer, this is the exact answer. It's not an approximation because we're leaving the pi symbol in it. Okay? When I say I do not want the approximation, I don't want you to multiply that by 3.14159 or the pi button. However, IXL is a computer system. It's a computer program. It's designed to read like a correct answer. And so if you don't follow their instructions, like they say use 3.14 for pi and then round to a certain value. Okay? It's not the greatest estimate, but that's what they're going to say is the right answer. And if you don't follow that way, then you're going to get it wrong. So make sure that you follow those instructions, okay? All right, here's what we're going to do. I'm going to give you another homework paper. I'm going to circle some practice problems on there, and I'm going to combine those practice problems with an IXL, and that's going to be your homework for when I see you on Tuesday, for us when we begin our class. But then you'll have the remainder of the time here today to practice, okay? So let me give you that paper, and then I'll tell you which ones we're going to do. We are going to do 1, 2, 3, and 4. Yeah, that's a good idea, Samir. No, I'm just kidding. And then let's do 9 and 10. Now, I'm going to give you a hint on 10. Okay? I'm going to give you a hint on 10. Let me see if I have it on my paper here. Okay? This line here on 10 is coming across, and you've got this height right here, and you're missing a radius, huh? Right? Because you got a cylinder here. Okay, there's your hint. All right. Here we go. Getting working, getting working, getting working.
Wait.